Hey folks, so here's the video answer key for the lesson 1-2 worksheet. This one's going to be a little bit weird because I actually had to go through and draw the constructions for 18, 23, and 26 first because I didn't want to worry about doing them while I was live on video, but I can talk you through what they look like. So starting with number 10, how could you use a compass to determine if two segments are the same length? So essentially, in order to do that, all you really need to do is have a compass open to measure the length of one segment and then keep it open and compare it to the length of the next segment. So let's see, how could we write that? We could say, open the compass to the length of the segment. So open the compass to the length of the segment. Then keep it open and place it on the new segment. Then keep it open and place it on the new segment. Just like to see if it matches, right? To see if the endpoints match. To see if it matches the endpoints of the new segment. Of the new segment. I was hoping using an iPad would make my handwriting better, and it's not looking like it's going to do that, but we'll see. I'll get better over time. So number 12, in the figure shown, suppose the measure of angle ABC equals n. So this entire measurement from there to there is n degrees. And the measure of angle ABD is twice as much as the measure of angle DBC. All right, so if we say that, we can say, all right, here's DBC. Let me get a pointer out here. I think I have a pointer. Yeah. So here's DBC. And instead, I say, well, this is half as much as angle ABD, right? Measure of angle ABD is twice as much as the measure of angle DBC. So what I'm going to do there is I'm actually going to make the smallest angles. I'm going to call each of them x. Instead of doing them as one angle, I'm going to call them two smaller angles. So that means that angle DBC then, angle DBC is actually 2x units. And if angle ABD is double of that, that makes angle ABD 4x units. So then, so the angle bisector of angle DBC is BE. That's how I knew that I could put an x here and an x here, because I knew they were the same measurement. What is the measure of angle EBC? And when it says what is the measure here, we don't know any numbers. We just know that this entire angle is n. So I know that 4x plus x plus x equals n degrees, but I don't know how much n degrees is. But I can solve the equation anyway. I can say 6x equals n and divide both sides by 6 and say that x equals n over 6, or 1/6 n. So if I'm writing my answer, I would say the measure of angle EBC equals n over 6. I think I've just learned I can draw straight lines. So we're going to practice that because I am really bad at drawing straight lines. There we go. So the measure of angle EBC is n over 6 degrees. Number 14, Adam is asked to construct the bisector of angle R. Explain the error in Adam's work. So when Adam went to make this bisector, do you see this arc right here? Instead of starting on point R and making an arc through both sides of the angle, he just picked a random point on one side of the angle and he just made an arc to the other side. And that's not how we need to make an angle bisector. So how could we write that? We could write he made an arc from one side of the angle to the other. He made an arc from one side of the angle to the other, when what he should have done was he should have put the compass point on R and made an arc through both sides of the angle. So instead of putting the compass point on R and, oops, capital R here, and making an arc through both sides of the angle, and making an arc through both sides of the angle. All right. Then we've got number 18 and 19 where we were doing those constructions. So if you look at my page here, I have the lines that I would have drawn in purple and then sort of the guiding lines that I would make little arcs with and pencil and stuff in gray. So make sure that when you have 18 and 23 here, your lines look like mine. You have an angle bisector for number 18. Make sure you've got the little, here, let me outline. Make sure you've got these little hash marks over here to show how wide the angle is, and then you've copied it from here to here. You've got this X to show the bisector. And then in 23, it says, where is the intersection of the perpendicular bisector and the angle bisector of angle E? So the angle bisector of angle E should be the same process as you did up above with the two arcs out here and the arcs on either side of the angle. See, I lengthened the side of E to make sure that this arc could be long enough. And then for the perpendicular bisector, of course, we are going to end up starting at G and F. We can make those arcs all the way out. So we put our compass point on G and one point on F and go out and out. And then we find our angle bisector, or sorry, our perpendicular bisector rather. And then what I didn't put in is there should actually be another X kind of out here as well. Ooh, that's a new tip. That's not a pencil, that's a crayon. Okay. So number 22. The quilt block is designed from a square using only perpendicular bisectors and angle bisectors. Write instructions for constructing the pattern in square ABCD. You may find it helpful to name some additional points. So if we wanted to take this design on the left and move it over to this design on the right, how would we do that? So I'm thinking maybe the first thing we would do is we would have to find this point right here, right? And this point right there is essentially the perpendicular bisector of AB, right? I could make this right angle here, find the perpendicular bisector of AB. Maybe we'll call it E because we want to call it something. So step 1, find the perpendicular bisector. Find the, I'm going to use the upside down T shape for perpendicular bisector of AB, which is called E, since I put an E there. Then, once we have that bisector in there, I can go ahead and make angle bisectors. So if you look at the diagram on the colored side here, you can see that this line right here and this line right here are the angle bisectors. It's hard to tell when we're looking whether the yellow to blue line or the blue to green line is an angle bisector, but this one right here is an angle bisector. So I am going to say that we're going to make the angle bisectors, and I'm going to name the angles. I'm going to say number 2, we're going to make the angle bisectors of angle AE, oops, I need another point here. We'll call this H down here, of angle AEH. So the angle bisector of angle AEH is going to come out like this. And we also want the angle bisector of angle BEH. So the angle bisector of BEH is going to come out like that. Right? And we can say that those are going to be the bisectors. Once we make those angle bisectors, we're going to make the other two angle bisectors that create the last two lines of our quilt square. I'm going to add in some more letters. I'm going to call this F over here and G over here. So then step 3 is going to be making two more angle bisectors. We're going to make the angle bisectors of angle FEH on the left. FEH, we can draw that in there. And angle GEH as well. And we can draw that in there as well. They're not exact because I can't draw exact lines with this program, but that is the directions on how we would make that pattern. Let's go to number 25, some good old-fashioned algebra to do here. So for number 25, a school gym is divided for a fair by bisecting its width and length, right? So its width is bisected and its length is bisected, and then each half of the length is then bisected, forming 8 sections in all. What are the dimensions of each section? So easy enough to show here that we know if the perimeter is 300 feet, we can make an equation to find out the side lengths. We can say that 2x's, so the left hand, where's my pointer? The left-hand side plus the right-hand side, that would be 2x, plus the top side and the bottom side. Altogether, that would be 3, because 1.5 times 2 is 3, so 3x equals 300 feet. So 5x equals 300, divide both sides by 5, and we find that x equals 60. So we can use that, so 60 feet on this side, and 1.5 times 60 is 90 feet on this side. And then if this is split in half, that means we have a 30 by plus 30. 90 split into 4 is going to be 22.5 for each of these. 5, 22.5, 22.5. And then we can say, all right, the dimensions and area of each section would be 22.5 by 30 feet, and that would make it 675 feet squared as the area. And there's our answer. Number 26, another one where we had to draw. So a 6th wind turbine will be placed near the intersections of the bisector of angle BCD. So the bisector of angle BCD is this line right here. That's our bisector of EBD, or BCD, sorry. And the perpendicular bisector of AE, so this line right here, and ED. So when we make all of those lines, we find that they don't intersect at exactly one point. But we also see that in our question, it says, what is a possible location? So that means that we can pick some location that is close to the intersection of all of these. So maybe if I want to pick a good coordinate point, I could pick 10, 10 there, and I could say 10, 10 would be close to the intersection of those 3 points, or those 3 lines rather. 27. The angle bisector of angle NPM is PQ. Let's draw that. So we're going to have an angle, and we have an angle bisector in there that cuts that in half. So we have angle NPQ. and it's got an angle bisector of PQ. So there's a Q over there. Write an equation that describes the relationship between the measure of angle NPM, that would be the measure of the entire angle, and the measure of angle QPM, that's this right here, right? And that's fairly easy to see. If we want to write that equation, we could write the measure of angle NPM, the whole thing, NPM, is equal to twice the measure of angle QPM. Or we could do it the other way around, and we could say that the measure of angle QPM is half the measure of angle NPM, right? We know that an angle bisector means that we have equal angles right there. Those were kind of messy, hold on. That we have equal arcs right there, equal angles. And then finally, number 28, a perpendicular bisector of segment DC is line AB, and a perpendicular bisector of segment AB is DC. Let's draw that. So we've got line DC, DC, and it says a perpendicular bisector of this line is line AB. So there's a line. We're going to pretend that's perpendicular. We can draw the little perpendicular, and it bisects DC. So we know that this side is bisected. And a perpendicular bisector of line AB is DC. So we also know that AB, the line here, is bisected by DC. So we know that this is also two congruent segments. And of course, the intersections of AB and DC are at point E, so we can call this point E right here. What equation is true? So we've got all of these possibilities. Is AB equal to CD? We don't know that because AB and CD are two different lines with different lengths, so we don't know. CE is congruent to CD. Well, CE is half this length and CD is the whole thing, so it's not that. DE is congruent to CE. DE is here, CE is here. They're marked congruent, so that is going to be our answer. And then, of course, we can continue through and see why the other two don't work. All right, so that is everything for the 1.2 worksheet. Make sure you ask any questions that you have in class so you fully understand this material, and have an absolutely fantastically wonderful day.